Suppose that a point P moves around a circle with a center at the origin and a radius r at a constant angular speed of omega, radians per second. When its initial speed is r, 0, we're going to express x and y as at t as t. We're also going to find an expression for the velocity and acceleration, find the speed, and also show that the velocity and acceleration vectors are always perpendicular to each other. So here's a little drawing of it. We have a point P. This is our point P, this purple right here. And it's moving around a circle from the origin, and radius r. My r is in blue. And this is your angular speed here. So that's your yellow. All right. When its initial position is r, 0. So first we're going to express our x and y as at t as t. And basically that means at point x, y, that's going to be r cosine of omega t, r sine of omega t. All right. That means our x equals r cosine of omega t, and our y equals r sine of omega t. Now for our velocity, all we have to do is differentiate our x and our y. So our velocity is going to be a derivative of x with respect to t, and that equals negative r omega sine of omega t, and our derivative of y with respect to t equals r omega cosine of omega t. All right, so that's your velocity of t equals your derivative of x with respect to t, comma, derivative of y with respect to t, which we just did, and that equals negative r omega sine of omega t, comma, r omega cosine of omega t. And just write it as a vector. All right, now for our acceleration, we have to take the second derivative. So for our second derivative, we'll get derivative of x with respect to t. That's going to give me negative r omega squared cosine of omega t. And our second derivative for y with respect to t is going to be negative r omega squared sine of omega t. Therefore, your acceleration of t equals your second derivative of x with respect to t, and second derivative of y with respect to t. And we can write it as equal to negative r omega squared. I'm just copying this down again. Omega squared, and then negative r omega squared sine of omega t. These are both t's. All right. Now to find the speed. This is your a of t. For your velocity of t, that's just your distance, where you take the absolute value of your velocity of t. So that's just going to be the square root of what we had on the other slide. I'll copy it down. It's going to be negative r omega sine of omega t squared plus r omega cosine of omega t squared. I got it all in. All right, let's factor out our r omega squared. So that's going to give you the square root of r omega squared times sine squared omega t plus cosine squared omega times omega t, or of omega t. Now what happens is this just equals 1. So your speed is just going to be the square root of r times omega, then squared, and that just equals r times omega. So this is your speed right there. I'll put it here. All right, and the last step is we have to show that our velocity and acceleration vectors are always perpendicular to each other. So basically for that, we're just going to use the dot product. And that means we're going to take our velocity of t dot acceleration of t for our vectors. That's going to give us equal your negative r omega sine of omega t, r omega cosine of omega t dot, and then the other one is negative r omega squared cosine of omega t. I'm going to squeeze this up here. Negative r omega squared sine of omega t. So that goes there. And I'll fix it up in a minute. And recall, let's write this out. Our x, again, was r cosine of omega t, and our y was r times sine of omega t. Now, when we figure this out, what I'm going to do is substitute in my x and my y. So that's going to give me r sine of omega t. So that's going to be negative. We still have this omega, and the rest is just y using substitution. And for this piece, we have r cosine of omega t. Well, that's your x, but we still have this omega. So this is going to be omega y dot, and do the same for this side. And you're going to get negative omega squared times x, because this is your r cosine, which is your x, and then negative omega squared, and then we have our sine, our r sine, and that's going to be y. All right, now let's go ahead and apply the dot product. So for these two, you're going to get negative omega y times negative omega squared x, then plus, now for these two, this is going to be, let's see, omega x times negative omega squared y. All right, when you figure all this out, this is going to give you omega cubed xy, because we have two negatives there, minus, for this one, omega cubed xy, and it equals 0. Since it equals 0, if this equals 0, that means our velocity of t is perpendicular to our acceleration of t. So our velocity and acceleration vectors are perpendicular. Thank you. Have a nice day. Bye-bye.